Okay, so let's talk about combining like terms for a minute. Combining like terms just means that when you're adding and subtracting, there are two conditions that you need to require in order to know if they even can be added or subtracted together. The first rule of combining like terms is that they have to be the same variable. Now you'll remember that a variable is any letter or symbol that stands for an unknown amount of something or an unknown worth of something. So X, Y, the Greek letters, alpha and beta, smiley faces, watermelon emojis, anything, so long as it stands for an unknown. So it has to have the same variable, usually X and Y, and the second requirement is that they have to have the same power or the same exponent. So another way to say this would be to say that they have to have the same letter or same letters, and it has to be to the same power. So let's use an example of this. I can combine 1 and 11 because they are both numbers, right? They have the same variables in the fact that they have no variables at all. It might be easier to say that x and 11x can be added together because they have the same variable. They're both x terms. Like that, these numbers can be added together because they're both number terms. Now, we've grown up assuming that we can combine numbers because that's what we've been told all our lives, right? But this is kind of why. It's because they're both the same kind of thing. They're not apples and oranges. So in the same way, we could say that we can't combine x and y. We can't combine those two. That does not equal xy. We can't combine them because they're not the same letters, right? We could combine x and x, and that would be 2x, or y, and that would be 2y, right? So let's take a look at some tougher examples. Let's say we've got 3r plus 3 minus 6r. Okay, so here we have some things we can combine and some things that we can't. Remember our first two rules, or our only two rules. Do they have the same letter? Well, let's look. 3r and 3. Well, they don't have the same letter, so we can't combine them. What about 3r and negative 6r? Please remember that the sign in front of it is super duper important. So we can combine 3r and negative 6r because they are the same letter to the same power, right? So let's go ahead and combine them. I will almost always, in fact, I always underline the things that I'm combining so that I can keep track of what I've combined and what I still need to combine. So 3r minus 6r, or 3r plus a negative 6r. They're the same, right? Adding a negative is the same as subtracting. Adding a negative is the same as subtracting. So 3r minus 6r, if I started at a plus 3 and I go down 6, I'm going to end up at negative 3. So negative 3r, we have to keep the letter, plus 3. Can I combine these two? Well, I can't because the 3 doesn't have an r and the negative 3 does have an r, right? So they don't have the same letter to the same power. So that's it. That's as simple as I can make it. Albert Einstein is attributed to saying, make things as easy as possible, but no easier. And this is what he meant. Okay, maybe it's not what he meant, but it's a really good application of it. So combine things that can be combined, but please don't combine things that can't be combined. It will not give you the right answer. So let's try something else. Let's say we've got 7n minus 4 minus 8. Well, that's not too bad, right? We can see that the 7n can't be combined with the minus 4 because they're not the same. But we can combine the minus 4 and the minus 8. Hopefully you can see that those are both numbers, and so we can combine those. So let's do that. I'm going to bring down the 7n because I haven't done anything with it yet. But a minus 4 and a minus 8 combined. Let's think about that for a second. So if I put those two together, I have a negative number and another negative number that are being squished together. That's addition, right? We're combining them. So a -4 plus a -8. Well, remember, we said just a minute ago, adding a negative is the same as subtracting. So -4 minus 8, either way you want to look at it, this is going to be a -12. If I went down 4 and then went down 8 more, that means I'm going to go down a lot, right? That means I'm going to go down 12. So remember our practice on combining integers, on adding and subtracting integers. Can I combine a 7n and a -12? I can't. So this is as simple as it gets. Now, this does get a little bit more complicated. So let's talk very quickly about the law of distribution in combination with this. We already know that the law of distribution says that if you have a number outside of parentheses, and some of you called this the rainbow method in middle school, that we are going to distribute what's outside of the parentheses to everything that's inside of the parentheses. So let's talk about this. 4 times x, remember, if there's no math operation in between them, it's always multiplication. 4 times x is going to be 4x minus 4 times 3 is 12. That's the law of distribution in a nutshell. If I have candy on Halloween, I am going to distribute it to everybody that comes to my door. So the 4 could be me with the candy, and the x minus 3 can be all of the kids that came trick-or-treating, right? So 4 times x gives x, the times 4, and 4 times 3 gives 3, the 4 as well. So remember that we're multiplying those. Okay, so how this plays into multi-step equations, which you're going to have to learn about and do in a minute, and combining like terms, is that you can have an example like something that follows like this. So if we've got 7x plus 7 times the quantity of -7 plus 5x. So, am I distributing anything with the 7x? No, that's going to stay the same. So let's go ahead and drop that down. But I can see that I'm going to need to distribute this 7 to the -7 and to the 5x. So let's do that. 7 times a -7 is -49. Plus 7 times a 5x is going to be 35x. When you're multiplying things together that have letters and things that don't have letters, multiplying and dividing, anything goes. It's okay. Adding and subtracting is when you have to have the like terms. Multiplying and dividing, everything goes. But when you're doing that, remember that you're going to multiply the numbers together first, and then you can deal with the letters later. We're going to talk about that when we start talking about the rules of exponents, but that's kind of a heads up. So 7 times 5 is 35. Now 35 is still times x, but we don't know what x is, right? Going back to the plus -49 right here, adding a negative is the same as what? Adding a negative is the same as subtracting, right? So 7x minus 49 plus 35x. Da-da-da. So there's lots of magic or math rules at play, right? So let's start combining like terms. Can I combine anything with the -49? No, because everything else has an x, right? So when I'm combining other things, I'm going to underline them with different numbers of lines so that I know what I'm combining and what I'm not. So I couldn't combine anything with the -49, but I don't need to erase my line. I'm just going to underline the x terms with 2 lines instead. So now I can combine my 7x and my 35x. Both of them are positive. 7 plus 35 is how many? That's 42, isn't it? 42x, and I'm going to drop down my -49 because it hasn't gone away. Can I combine these two? No. So this is my final answer. So I hope this has been helpful in helping you to understand a little bit more about the law of distribution and a lot more about combining like terms, because we'll be doing a lot of that for pretty much the rest of the year. Thanks for tuning in, everybody. We'll see you next time.